conversations about carbon in the future. So I think that's what I have to get us started. So Bill, thank you so much for your willingness to embark with us on this journey and be the test case. Really appreciate it.
Well, thank you, Lisa. Thank you for inviting me, Lisa. Well, we'll see how it goes. I do have to apologize. My internet seems to have gotten a little flaky all of a sudden, but I hope it doesn't interfere with the conversation.
Can hear you good on my end. So hopefully others can as well. So as we discussed, I thought we'd start out talking about some of the work that you've done with relation to the IPCC, Intergovernmental Panel on Climate Change, which was the team that you were involved with, was awarded the Nobel Peace Prize in 2017 for your efforts to build up and disseminate greater knowledge about man-made climate change and to lay the foundations for measures that are needed to counteract such change. So that's a big deal. I mean, we've all been hearing about Nobel Prizes since we were children, and for environmental scientists to be a part of a team that received a Nobel Prize, that's really cool. Can you tell us a little bit about, kind of behind the scenes, what that work looks like, and how did it feel to be a part of a prize-winning team like that?
Well, it certainly was quite an honor, although it's great to be part of that whole organization. I would point out that there are literally thousands of people involved. So, but nonetheless, it certainly was exciting. I remember I think I was driving my daughter to school one day when they announced it, and I said, "Oh, your father worked on that." Being like a kid, she just kind of rolled her eyes and didn't give it much attention. But it's a huge enterprise. Even on the current document that I'm working on, there are 3 working groups. And in my working group alone, there are over 300 people involved between authors and support staff and everything. There's a lot of work we do trying to just update and trying to understand what the current literature is telling us. It's based heavily on the peer-reviewed literature, and then some other things like the most recent accepted computer simulations. And we have to kind of keep track of that as we're writing things. And it's a 2 to 3 year process. It's been stretched out some with the pandemic. And so that means not only do we take what was there when we started, but we have to keep an eye on what new is coming out as we go along. And there are several review steps along the way. This particular round, there were 4 major reviews of what we did, and we have to respond to those review comments. And it's all about trying to make sure we have a coherent report, that different parts of the report don't say things that disagree with each other, which would be a problem that has sometimes occurred. But most of it is just trying to keep on top of everything that's happening. Lots of conversations among ourselves, lots of Zoom meetings. Because it's a worldwide group, that has meant lots of Zoom meetings for me at 7 in the morning, which is not really my time of day. But nonetheless, it is gratifying to be part of a global community like this. I learn a lot from all of my colleagues. It's great to be part of a project with a lot of other really smart people. There's a lot you learn along the way, and you hope that you've made some good contributions yourself. So it's like writing a scientific paper, but a big one that takes a long time to work on.
Right, and so many co-authors, right? I can't imagine navigating sort of the expertise of so many people.
Lots of interesting discussions. We're usually pretty polite with each other, but there are certainly disagreements that come up along the way, and we have to talk about them and resolve them. So, and it's, as long as I'm on the sidelines for some of those so-called interesting conversations, and it's just fun to listen to it. But I get involved myself with some of them. But that's part of the process, trying to make sure we arrive at the best understanding of what we're saying and why we're saying it. So it's a great process, a lot of work.
I bet. And a lot of early mornings, it sounds like, for you. Let's bring it local a little bit. We've talked about IPCC with this global effort. How about Iowa's role? What are some of the expected impacts of climate change? What are the opportunities for Iowa, especially in carbon removal and reduction?
Yeah, I mean, the whole notion of carbon removal and reduction is really exciting because certainly one of the ways that people in Iowa and people around the world contribute to climate change is through the burning of fossil fuels. And it's great that there are this really substantial effort to not only reduce our carbon emissions, but also try to remove carbon from the atmosphere. Here in Iowa, in terms of impacts, some things we've seen, looking back at some records I've looked at over the past century, is that summers have not changed too much in that the hottest temperatures have tended to be about the same. And I think that's largely because we've been getting more humid here in Iowa. So that has been a change. And if it's more humid, it means we've been getting more rain falling, and that keeps the ground wetter. And as you know, when you step out of a swimming pool and you feel that chill as you step out, well, that evaporation from the surface acts to keep daytime high temperatures from going up substantially. On the other hand, in the winter, we have seen warming. We had this cold snap back in February that seemed bitterly cold, but when I looked at the records, at least for Ames, Iowa, that was the first time in this century that we had this multi-day extended cold snap like that. If we go back to the beginning of the first 50 years of the 20th century, we had about 44 of those events. In the second half of the 20th century, we had about 22 or so. And so now we're, well into the 21st century, and we've had only one. So the winters in particular have been getting warmer. And then, with that higher humidity, we've been getting more intense rainfall occurring as well. Higher precipitation amounts throughout the year and more intense summertime rainfall. So those are things that have occurred already and that we would expect would continue going on into the future. How much things change, of course, depends on what we people do with regards to fossil fuels. And it again comes back to very exciting developments with reducing carbon emissions, but also trying to take carbon out of the atmosphere, which I think is one of the most sensible ways to approach this, in contrast to some other so-called geoengineering topics I've heard thrown out there.
Great. Awesome. And one of the things you talked a lot about impacts to Iowa. And of course, when we think about Iowa's role in the country and the world, the first thing that comes to mind is agriculture. So how about impacts to Iowa agriculture and the role that Iowa agriculture can play in carbon reduction and removal?
Yeah, well, of course, in some ways you're more of an expert on this than I am. But what I would say in terms of the changing climate is things that have an impact on agriculture, thinking about the summertime, those heavy rainfall events can end up causing soil erosion. They obviously can produce crop damage. The higher humidity helps, supports the growth of things like molds and things of that nature, which are not great for crops. And then also even in the wintertime, because the winter temperatures have tended to be warmer, those very bitterly cold temperatures help kill off a lot of agricultural pests. And in days gone by, they would get killed off quite a good way south of us. As the winters have gotten warmer, it's meant that some of those agricultural pests can winter over at latitudes or locations closer to us, which means they don't have to travel as far north to get into Iowa during the growing season. In the past, they might arrive in Iowa about the time that our crops were maturing, and so they were less of a problem. But now they have a chance to show up even sooner, and that creates a problem as well. So even the winter changes have an impact on agriculture. On the other hand, as you know even better than me, Lisa, agriculture over the many decades that it's been going on here in Iowa has tended to deplete carbon in the soil. And that means that there's potentially a great reservoir for taking carbon out of the atmosphere and putting it in the soil, which has further benefits. As I understand it, it can make the soil in some sense healthier and actually promote better crop development. So there's some other additional effects besides just being able to take carbon out of the atmosphere. But that certainly is one of the things that I really like about this carbon removal opportunity, because I get tired of hearing farmers get beat up about this, that, and the other thing related to environmental issues, especially when people don't understand that they're trying to run a business. And if they don't run a business, they're just gonna fade away. So I really like the opportunity for farmers to really be part of the solution in a very big way. I think it's just a great way to show that agriculture is really a key part of what we have going forward in terms of the whole climate issue. And it will help out farmers as well if we can mitigate those changes that I've already talked about that impact agriculture.
Wonderful. Great answer. So one of the things I wanted to talk with you about is engagement. You've been working in this space for so long and have had great experience in terms of working not only on the IPCC, but with our elected officials, with campus administration, with students, with local communities. So what have you learned in those experiences about engaging communities in conversations around climate change? And what can you recommend for scientists, instructors, in terms of proactively engaging communities on climate change, carbon removal, and reduction?
Sure. Well, I'll start off with what was the old model that we have come to understand just does not work. People refer to it as the loading dock model, where we would just put data out there and people could grab it and do whatever they wanted with it. They would not understand what the data was about. They would not understand what the uncertainties were in it. And we might not even be giving them the right data for them to work with anyway. So the key words more recently have been, in at least large parts of my community have come to understand this, is all this, what I would call co-production, co-exploration of the data, co-development of understanding. And what goes on with that is a recognition that you have to be in a dialogue with the broader community. You have to understand the context of how climate is important to a community. You have to understand what the community's concerns are with respect to climate. You have to understand the values of a community. Some things that we as scientists aren't normally always used to thinking about, and maybe even get a little uncomfortable thinking about. But if we don't understand the values that motivate people, then we're not going to be able to reach them, and we may turn off a lot of people. So that means that you have to think carefully about the people you talk with. To use another phrase, it truly takes a village. It takes all of us working together, and we have to understand what is important for people in different areas. We have to understand what's important for farmers to understand and know as they do their work. We have to know what city managers have to know in terms of how an urban environment might be changing. And we have to understand all those interrelationships. So it's much more complex than what we as climate scientists used to think about. I think a key question that I learned quite a few years ago now was, if you want to talk with someone, is don't ask them what they want. Instead, ask them what they do. Because if you understand what they do for their work, then you're going to start to understand much better what motivates them, where their values lie, and how you can really start a dialogue. And that dialogue is really vital to being able to communicate the information well, and to make sure that people respond in a way that is an appropriate level of response. Sometimes I get concerned that some people want to over-respond. And that could be just as bad as not doing anything. So that's I think a lot of what I've learned, and I think what a lot of my colleagues have learned, really in the past 10 years or so, in terms of understanding just what it is that you have to do to work well with the broader community, and to recognize, as part of that, to recognize all the expertise that's out there. I think there's this old academic impression of us in our ivory towers telling people the truth about the world, and obviously that does not work. And it takes a certain amount of humility as well. We have to listen, and that's not always easy for academics to do, because we're used to telling people things, whether it's in classes or in seminars or at conferences. We have to actually sit back and actually listen, and listen really carefully.
Mm-hmm. Ask really good questions, and to ask really good questions, we need to listen, right? So just to kind of summarize, moving from sort of that loading dock model of science communication to co-production is what you're saying, and shared values. Exactly. And recognizing where people are coming from. Yeah, that's a good way to summarize it. Okay. I want to bring it home to ISU for a moment here, and we'll open it up to the floor to questions very soon here. So can you talk a little bit about your experience leading the University Sustainability Committee? And in particular, last October, President Winterstein announced the 5-year campus plan to improve sustainability of campus operations. Can you tell us more about that plan and the engagement of the university sustainability community across all mission areas of the university?
Sure. Well, that strategic plan for sustainability and operations is something that I really have to give a real shout out to Mary Rankin, who is the sustainability director here on campus, and all the people in the facilities planning and management FP&M group that have worked with her to develop that. I had a little bit of input along the way, but it was really the people who are involved in the operations, people who are on the ground, who put together a great plan that involves issues of how we will reduce our burning of fossil fuels, reduce the carbon emissions, how we will engage much more thoroughly in issues of recycling, reuse, and basically even things like what sorts of plantings we have on campus, how we reduce our energy needs by just how we set up vegetation on our campus. And I apologize for that phone ringing in the background if you hear it. And it was a really well thought out plan. The University Sustainability Committee stepped in to review it. And one of the advantages we have is a committee appointed by the president is we have a direct line to the president. So we can tell her our advice, our recommendations. It also means that we're under her wing and we can't just go out and start promoting things on our own. But we told her, yes, this needs to be supported, this needs to be endorsed. And after talking with us, she went ahead and did give that message that you talked about earlier. We're now trying to work on furthering some further recommendations related to specific details of that plan. And we're also trying to address various educational issues. That's obviously a very complicated arena to get into. We have to make sure we understand what it is that we can recommend that will actually be very good. And we're trying to think about ways that we can infuse sustainability across the curriculum. Again, thinking about that whole notion of it takes a village. It's not just one discipline or two disciplines that are relevant here. It's every discipline that we have on campus has a role in how we promote sustainability. And with that, how we promote our resilience to changing climate and reducing the growth in climate change as much as we can. So we're trying, we're even, we're a very diverse committee. We have people from FP&M, we have students, we have faculty, and we're all trying to understand each other and also at the same time pooling our expertise to arrive at recommendations we can make to the president, who can then ideally accept them and go forward from there and really start to guide the university community towards better sustainability, both the university as a community itself and then the world we send students out into, how we educate, train our students.
On that theme of it takes a village, I'd like to shift here and make sure that we get as much time for the audience to ask questions as they would like. So Asrun, could you help us by queuing up a question for us?
Yes, first question from Adel Kaisi. Bill, what are your thoughts on the current report of CO2 levels reaching 421 ppm and temperature thresholds up to Fahrenheit, it looks like? So.
Well, it's not surprising in some ways. We have an infrastructure in place that's highly dependent on using fossil fuels, and we're not going to change that overnight. There certainly have been gratifying changes that I've seen in Iowa with the development of wind energy, and now a lot of talk about solar energy in Iowa. As a little side note, if all the wind energy we produced, all the wind electricity we produced in Iowa simply stayed in Iowa and didn't go into the grid, it would cover over 40% of our electricity consumption. So that's to me, that's just an astounding growth. So I expect that carbon dioxide level is going to unfortunately continue to decrease because it takes a long time to really start to reverse things. Ideally, over the next decade, we will make substantial progress in slowing that down and perhaps even reducing it some. Although I think if we can at least slow it down and flatten out the curve, as it were, that would be a major step. Even if we do that, we're going to continue to have some degree of warming going on, because what we have here is kind of like a spinning flywheel. We've got changes going on that they get, the oceans help and hurt us. The oceans kind of retard the growth because they have so much mass to them. But that also means that we've got warming that's in the works that we're not going to just stop overnight. So there's some further warming that will occur. And no matter what we do, what I've seen from past analyses and everything is, no matter what we do, as we go over the next 30 years, there's a certain amount of warming that will occur. What we're talking about here when we try to reduce our carbon emissions and even remove carbon is make things better for our children and for our grandchildren going on down the road. And so that becomes a very important process for us to engage in. It's the legacy that we leave for our descendants.
Good. Next question.
So here's a question from Basil Nicolau. We have had nearly 200 years of building structural infrastructure that's dependent on carbon. And I think new technologies need to be developed to replace this infrastructure. How does one prioritize?
I'm not an engineer. I know that as we move to perhaps to an economy that is much more dependent on electricity produced by renewable means, then obviously we have to change the infrastructure in terms of how that gets used. I'm sure you've probably seen talk going on about how we're going to provide charging stations for automobiles. I'm not quite sure myself how to prioritize it because I don't know the engineering aspects of this myself. It's easy for me to sit here as a geoscientist and say, oh yeah, we should build this or build that. I think there's some things we need to be perhaps focused on, which is how we store the energy we do produce. There's been a lot of effort with trying to develop batteries that can store the electricity, store that energy. I think there's other ways that people have been exploring it that I can't claim to have any confidence in assessing which ways are more effective or not. It probably will take a variety of different approaches to work. I don't think we should throw all of our eggs in one basket. I think we need, for resilience, we probably need to have a variety of ways of storing electricity and ways that we try to distribute or even produce electricity, whether it's small local grids that feed into a larger grid, larger infrastructure like major wind farms, things like that. It probably will be best if we have a variety of different sources, just because that wide variety tends to give better resilience. But again, I'm not an engineer, so I'm sure an engineer out there might be cringing and saying, no, you're missing some key points.
There's been really awesome engagement through the Q&A and in the chat from the audience. And for questions for you, Bill, it's really fantastic. Given some of your expertise, I want to make sure to focus on some of that. So one of the questions is, has the ISU Sustainability Committee engaged with student sustainability oriented groups in the effort?
We have had some discussions with the group called Climate Reality. In fact, one of the student members of our, maybe two of the members, of at least one of the student members of our group is a member of that. Student Jennifer Seth, and then there's another student whose name I'm sorry, I'm blanking on right now. They have been sustainability directors for the student government, and so we are connected with the student government in that sense as well. And we certainly welcome student input to what we're doing. And that's why the president appointed 4 students to be part of our committee. 2 are undergraduates, 3 are undergraduates, 1 is a graduate student, because we recognize that, one, they have a different perspective on these matters, different types of expertise, things that we may not be aware of ourselves because they're keenly interested in the subject, and also because they're the ones that are going to be inheriting the world going forward, and they certainly deserve to have a say in all of what's going on. So we do have some degree of student engagement. I think we've talked in this whole educational aspect of matters about how we might try to have even stronger engagement with students, perhaps through something that we might call a sustainability day or something like that, where we bring together all the different sustainability groups, activities on campus, and try to work with students and other groups on that issue.
Super, thank you. Azrin, do you have another one you want to prioritize?
Yeah, I think, well, I think I want to go to this one here because it's about for Christopher Anderson about ethanol plants having in place carbon removal and sequestration system that's being implemented. And I'm summarizing a little bit, by redirecting the stream to carbon sequestration, financial benefits go to ethanol facilities, but not necessarily to farmer. And this is a complicated question, maybe too complicated to answer on the spot, but how would scientific assessment determine the value of ethanol carbon sequestration versus perpetuating fossil fuel use by the ethanol industry to obtain carbon sequestration?
Oh my goodness. Well, I'm not an economist. I'm not sure I can give a really clear answer to that. I think that certainly anything that reduces the carbon emissions into the atmosphere we have to start off at least with a positive perspective on it. Then there's all these deeper questions like how much do farmers benefit by contributing to this, or how much are they just being pushed off to the side? Those are key questions that need to be thought about in many ways. One of the things that concerns me a little bit with some of the carbon removal measures I've heard about is people talk about storing the carbon, say in large underground caves, which sounds like it could be held there indefinitely, but I always get concerned about possible leakage and what would happen, because you could start to get large burps, if you will, of carbon dioxide into the atmosphere if it's truly not contained for long periods of time. This question came up many years ago when people were talking about storing used nuclear fuel safely. And it was kind of a same kind of issue that you have to be able to store it for a long time. What I like better is when people come up with ways of locking the carbon into something that is more stable, which could be like in the soils or other ways of doing it. Even if it's like growing trees and the wood becomes a more stable way, I believe, of storing carbon. Again, this is going way outside of my expertise. So there may be people out there in the audience who have better ideas than I do about this. But I think a key point here is to recognize that these the solutions are not necessarily always very simple and straightforward. And we are living in a complex world. We have a lot of infrastructure that's in place already. And this transition is going to take a lot of careful thought. Again, I think we need to have multiple approaches to this transition and not try to just rely on one single approach as being the answer to everything, because we don't necessarily know what all the further downstream effects are of any particular approach. And we need to give ourselves opportunity to adjust and try out a variety of approaches that may work equally well, or some may turn out to have some bad side effects that we just hadn't thought about until we started working on them. And those bad side effects aren't necessarily environmental. They could be economic effects, social effects of some kind that I can't imagine myself, but we need to be aware of all these different possibilities.
There's several questions here about the 45% reduction target for GHGs, greenhouse gases, by 2030 as a recommended target. Is that enough? What do you think?
Well, it's the starting point. We have to really stop adding more carbon dioxide and other greenhouse gases, but especially carbon dioxide to the atmosphere. So when people come up with targets like that, what they're trying to do is think about something that's realistic, getting to a certain point. But we should not say achieve that and then feel like, oh, we've solved everything. Everything is just fine now. it's a step in the right direction. Ultimately, the key goal is to not have, excuse me, not have carbon dioxide levels increase in the atmosphere, and ideally perhaps even decrease some. How much they should decrease becomes an open question itself, because when we start talking about changes in weather and climate, well, different parts of the world experience that in different ways. And one small example, one of the outcomes of the warming of our planet is that sea level is rising, partly because of the small expansion of seawater, and then also all the glacier melt that goes off into the oceans. That affects island nations, so they're being severely affected. They might even disappear in some cases. So they might argue that we need to reduce carbon dioxide levels substantially so that we can get back some of the land we're losing. Other people may feel like, well, but now you're going to make things colder where we had already adapted our agriculture, and now we're not going to be able to do this agriculture we adapted to. So it gets into very complex global issue, and there really needs to be a lot of discussion about issues of equity around the world in terms of where we might, assuming we can pick a level of CO2 that we end up with. We need a lot of discussion about just how you arrive at that in an equitable way, because it's not like there's clear-cut winners or clear-cut losers in any of these choices, but we need to make sure that we're responsive to the needs of the whole world as best we can be.
Super. Ezrin, do you have another one queued up?
Yeah, from Robert Brown, some environmentalists oppose carbon removal, arguing it will encourage use of fossil fuel. How do you bring them on board?
I didn't hear all that. They argue what about against carbon removal?
That carbon removal encourages use of fossil fuel. How do
okay.
you?
Yeah, no, I see what you're saying. Well, you could make the same argument with some of these other geoengineering things that people have talked about. People have talked about putting aerosols into the stratosphere to act kind of like volcanoes do, which reduces the amount of sunlight reaching the surface of the earth, and so it could retard warming as well. And that is a possibility. Carbon removal to me seems like a much better approach than that. But I think that, again, we have to explain to people just what goes on here, and to help people see the bigger picture, and that further use of fossil fuels, just because we can take it out of the atmosphere, is not necessarily a solution. There are expenses involved with some of these carbon removal strategies. And also, I would point out that fossil fuels are becoming, as I understand it, becoming harder to mine. And so their cost is going to go up anyway. I believe, someone else might know better than I do, but I believe right now that coal, for example, is not very economically competitive compared to wind and solar or natural gas, because it's become so expensive to produce it as a fuel. I think we need broader education all around. I think that argument, I understand why people might have a fear of that, but I think we need to have people understand that if we want a truly sustainable world, we have to move away from fossil fuels and not have to worry constantly about pulling more carbon out of the atmosphere.
Bringing it back to your experience with the IPCC, there's a question: when is the next summary for policymakers, the physical science basis? When will that be available?
There is a meeting of the final meeting with the government representatives that's currently scheduled for July, I believe. And that is where it gets approved. And as soon as it's approved, that summary for policymakers, this would be just working group 1 only, gets released. So we're talking about that time frame. That's sometime in the middle of northern summer. The full report should be coming out at about the same time, but I know there's always a lot of copy editing that's going on. It's even going on right now. In principle, it should be coming out about the same time and be accessible to people. But the summary for policymakers, which is the key focal point, should be available, barring any further delays because of the pandemic, sometime in July or early August.
Okay. So just around the corner.
Yes, ideally.
Mm-hmm. So this will be our last question. We want to wrap things up by 12:45 to give folks a little bit of time to have a break before potentially they have a 1 p.m. meeting. So we plan a hard stop at 12:45 Central Time. Azrun, you get to pick on the last question.
Okay, yeah, I think actually here's a relevant one. With agriculture representing the largest source of greenhouse gas emissions in Iowa, what incentives do you believe would engage the agricultural community? Methane emissions and nitrous oxide emissions are far more consequential GHG emissions, but yet they're inherent emissions from our agricultural production.
Yeah, it certainly is important to recognize that there are other greenhouse gases that are important, especially methane and nitrous oxide. Methane is on a molecule by molecule basis, as many know, is more potent as a greenhouse gas than carbon dioxide, but it also has a shorter lifetime in the atmosphere. So if we can control the emissions of methane, then we have great opportunity to reduce methane levels in the atmosphere, I think, just because what's there already will start to decrease substantially, at least the methane that's there from human causes. Nitrous oxide is, I'm aware of it, but what I learned at the carbon removal forum was that there's much more that goes on with it than I know about. And so it's got a longer lifetime, not as long as carbon dioxide in the atmosphere, but a longer lifetime. And so the idea of, as I see it, of reducing emissions is to level off that growth. And ideally over time, it would start to come down on its own. I'm not aware of possibilities for removing nitrous oxide, but other people here may know better than me. Clearly, there needs, again, these are not very simple problems. They involve complex systems, and there needs to be a lot of thought about the most effective way of combining different efforts to really, truly reduce the emissions in a way that works, especially for farmers, in a way that works so that we have lower emission rates. And also recognizing that, again, some gases stay in the atmosphere longer than others. And so we have to think carefully about what it is we're balancing. For example, people talk about burning methane as a fuel. Well, if you burn methane as a fuel, you're producing carbon dioxide. So yes, you've produced molecules that are less potent, but now you're producing molecules that are going to be staying in the atmosphere longer. So and that's really almost a trivial example of what needs to be done. People have to look at the system as a whole to really understand what is the best pathway or set of pathways forward.
Thank you, Bill. I'm gonna share my screen here to wrap us up. So a few key themes: it takes a village, co-production of knowledge and recognizing people's values, systems, approaches, right? Really key themes, as well as understanding more about what's happening at ISU with regards to our contributions in terms of reduction and removal of carbon from the atmosphere. So I want to thank you, Bill, so much for being our guinea pig today. We really appreciate your willingness to engage with us in this format, and thank the participants, 60 participants, really great questions and in the chat and through the Q&A. So appreciate people logging in over their lunch hour and also wanting to get their questions answered. We didn't get all of them answered, but your questions provide great fodder in terms of these future conversations, the experts that we'll bring in and be able to hopefully get more of your questions answered in time. So thank you. In terms of more experts, our next expert is going to be Dr. Lois Wright Morton. She's an emeritus professor of sociology. She's also a farmer in Ohio now. She moved back to Ohio after retiring from Iowa State. She's also a board member with a farmer group, Solutions from the Land. And she's going to talk about connecting agricultural carbon to sustainable development goals. So really thinking about, how do we scale from agriculture to meeting those global sustainable development goals. If you have the Zoom link for today's session, you can use that Zoom link for the next conversation as well. that we'll be using the same link for each session. So just save that, and we'll make sure to get the registration and calendar invite up to date for next time, so that the Zoom link is within it. And we're still working on setting up our May conversations, but we do have Dr. Frank Mitloehner. I really am not doing good on names today. So Mitloehner on June 2nd. At the end of the Carbon Removal Forum, people are great about providing us with other ideas in terms of continuing the conversation and gaps in terms of that particular event. And a key gap people talked about is the need to also represent animal agriculture. So Frank Mitloehner will help us with that. He's a professor and air quality extension specialist in animal science and director of the CLEAR Center at the University of California, Davis. He'll talk about a path to climate neutrality in livestock production. Looking forward to that. Other things that people told us they want more of is more about carbon policy and carbon markets. So we are trying to respond to your interest in lining up experts to talk about those topics. That will be coming. Again, we want to hear from you. What are some of the other topics that you would like covered? Who are the experts you want to engage with? Submit your ideas. The tiny URL there, I think Allie is going to put it in the chat, or maybe she just did. So you can submit your ideas through the Smartsheet form, and we'll do our best to get these folks on our agenda in the coming months. And it takes a village, as Bill said. We're all part of the solution. So you all have a job for today too. It's not just engaging through the chat, but I encourage you to share one thing that you learned from Bill with someone else in your community. And let's continue to build on this knowledge and make sure that the science basis for our decision-making in this area is well understood by as many people as possible. It does take a village. And with that, I just encourage you to enjoy the knowledge that you learned today from Bill. Enjoy the clear head with regards to some of the science on climate change and carbon reduction and removal. Take your passion, your full heart, and move forward with that. And let's go on our day and share that one thing with someone else today. So that's it for our first conversation about carbon. I hope you enjoyed the experience. And again, thank you, Bill, for engaging with us. And we hope to see you back in 2 weeks with Dr. Lois Wright Morton. It's a wrap.